Hello, my name is Tayson from casaGeo, the data science and location intelligence company. In the third part of the location optimizer macro, we will look at the parameters. So, what happens when we change speed optimization? What effects do these have on the results, and what happens if we run the model several times with the same parameters but different starting conditions? I have the following scenario. We want to enter the market in Schleswig-Holstein and want to open 20 shops in the first year. Each shop has a range of 10 kilometers and we want to exploit the greatest possible potential. All shops should be located in Schleswig-Holstein, but customers may also come from Hamburg. The structure of the two files is the same as in the last video, except that the file with the potential now contains 12,964 records and 12,279 grids are possible locations. The macro is also similar. We read in the potential file and the locations. We look for the nearest neighbor with a maximum distance of 10 kilometers. Now we calculate the potential per site with some overlock ID and then calculate the total. That is our score. And we want it to be as large as possible. We output the potential per location with the selected locations. We open the interface designer and select location as the potential locations input under properties and score as the score output. Since we want the maximum score, we activate optimize for a higher score. The macros from this and the last video are quite similar. However, last time we had 682 possible locations and this time we had 12,279. That's quite a different number. After saving the macro, I load the workflow. It looks the same as last time. SH potential contains the customer potential and SH location the possible locations. In the macro I select 20 new locations, set speed optimization to fast and random seed to specific. Specific means that we start with a specific scenario. If the value is the same, the starting conditions are also the same and we can see how changes in speed optimization affect the results of the model. We sort the new locations in descending order of potential and save the result. We also want to look at the lowest and highest potential as well as the mean and standard deviation. We run the workflow and look at the results. The workflow runs for 2 minutes 48 seconds and reaches a potential of about 3.2 million inhabitants. The strongest location has a potential of about 823,000 inhabitants and is located directly on the Hamburg border. A large part of the potential thus comes from Hamburg. The smallest potential is the location near Lake Ratzburg with about 33,000 inhabitants. Now I run the workflow again with speed optimization balanced and accurate. The table shows the starting point and the option. Surprisingly, the values for balanced are consistently worse than for fast and took even longer. With accurate we achieve a higher score. So we reach even more people, but the top store only reaches 774,000 people while the worst store reaches a higher score. The spread between the stores is not that big in this case. Of course, we can change the macro so that a store has to reach at least a potential of 150,000 inhabitants. If we run the workflow, we get only 9 locations instead of the planned 20. However, with a score of 2.5 million inhabitants. 6 around Hamburg, 2 near Kiel and 1 in Lübeck. Since no location has a potential lower than 150,000 inhabitants, this may well be a more realistic scenario. Let's return to our example and change only the starting conditions. We run the workflow 10 times. Is the effort worth it? Or are the results so similar that one run is enough? We get the smallest score with 3,308,614 in the 5th run and the largest with 3,473,390 in the 9th run. If the figures are for turnover in euros, the difference would be just under 165,000 PA. In our example, the time varies between 3.5 and over 8 minutes. In our example, it would certainly be worthwhile to run through several scenarios. Finally, let's look at the location distributions on the map again. We see that there are a few hotspots, but the locations are affected by the distribution of the others. Let's pick out Simulation 9 and draw a 10 km radius around each of the locations. As you can see, these sites here are not directly affected by any other site. In the next video I will show what this means and how I create a macro without Spatial Tool. That's it for today. If you liked the video, give us a like, and if you are interested in the topics of data science and location intelligence, then subscribe to our channel. Thank you for your time.